So moving on to the next presentation, this is coming from Dante Zeng, who is a product marketing manager at LONGi. He's going to talk about the journey of LONGi's HPBC 2.0 development, the latest IBC module from LONGi.
Yeah, hello everyone, and I'm Dante from the LONGi product marketing department, and let's share my screen, by the way. Can everyone see my slides?
Yes.
Okay, sorry. Yeah, sounds stuck. So my topic is about the journey of LONGi's HPBC second generation development, and because in this year, just 2 months before, we launched our HPBC second generation cells in the matrix span, and I think it's a huge jump for the overall industry because the efficiency is remarkable and it's very good. But how we achieve that and how is the journey of the LONGi's HPBC? It's about my topic today. Firstly, we just ignore the HPBC because it has very strong perspective. We just talk about BC itself from the basic principle about the BC technologies, and we can see that the BC could achieve both optical and electrical better performance compared to others, because from the optical, we can enhance light absorption because we have no bus bar and no fingers on the front side, so could achieve 100% light absorption, no reflection, no obstruction from the soldering process or the finger, and it's 100%, and it could increase the short current, by the way. And from the electrical side, we can optimize the passivations because we can combine all the advantage from other cell technology like the Topcon or the heterojunction. Because for the Topcon, its typical technology is their like tunneling oxide layer, and for the heterojunction, there are just 2 heterojunction layer from deposit on the front side and back side to achieve higher voltage, and the BC could all combine these technologies. And also about the electrodes, the electric connection side, we can choose the special elements. Also we can optimize all the finger and bus bar place and to achieve higher transmissions. So based on the optical and electrical performance, we can achieve higher efficiencies, and it's the highest theoretical efficiency compared to all others. I remember Topcon is theoretical efficiency is around 28.5, and heterojunction is around 28.7 or 9 around, but BC is the highest, and that's the reason why LONGi choose BC. And about other things, like BC also have its own authentic gift because there are no bus bar and no finger on front side, so it can perfectly match the environment. And especially in the residential scenario, some customers install the PV modules on their rooftop. If there are some finger and bus bar, it will make the appearance looks sometimes a little bit weird, but if we use the BC modules, it can perfectly combine with the environment and achieve highest level aesthetics. So there are another gift about BC is the reliability, because from the traditional cell and traditional battery, they all should connect one positive electrode to another negative electrode to achieve the overall current. But for BC, we integrate the positive and negative electrode all on the backside. So we call it one-line winding structure, and this winding structure could reduce the cell edge stress, and especially in some spot strike or some transmission strike. This this strike would occur the micro crack on the cell surface, and which is not very obvious from the eye side. But this micro crack could lead to the hotspot or the power loss or some reduction of our module life. From our own logistic department calculation and compared to our the last generation, like our PERC modules and also some competitors modules, our HPBC module could reduce more than 80% microcrack situations, and so that the customer's value could be guaranteed just because of this reliability gift. Then, based on these three key features, key advantages, LONGi decided to focus on BC technologies. Since 2017, which at that time the PERC is very popular, LONGi proposed an BC cell structure design, and after 4 years, we finally achieved it. And the HPBC first generation turned into mass production and achieved above 25% efficiency. And during this process, we invest more than 1 billion RMB and more than 1,000 people to do the research, because the BC is very hard, and it's I think it's very generous. And its difficulty is very well known in the industry because it requires very high level, like the planting technologies, laser planting, or very high level very high process level planting technologies, and also about module layer part deposition. Is all very difficult, and the cost is very terrifying. So we have a lot of breakthrough so that we can turn BC into mass production firstly in the industry. And this year, as I mentioned before, we updated our first generation to second generation, and our efficiency crossed another big leap to achieve more than 26%. Yeah, that's our BC. I think there is a very generous misunderstanding about HPBC, because there are some market colleagues think our HPBC, that P means PERC or P-type wafers. But actually, the answer is not, because this P means passivations, and our HPBC means hybrid passivation BC. And it cannot just be recognized as one very simple technology like TBC or HBC or IBC. It's a hybrid passivations, and we combine all the technologies to increase the efficiencies. And just this structure is about our first generation HPBCs. And we have some very special, like sub-micron texture on the surface, and we do the hydrogen passivation from the double side to increase the efficiencies. And at that time, because it's our HPBC first generation turned into mass production, and 2022, and that year, I think the overall industry is at the crossroad, because the PERC, we can see the peak of the PERC is already passed, and which technology we should choose in the next generation, next century. And at that time, we published HPBC first generation, and there is a cross-generation upgrade compared to PERC, because our module efficiency increased more than very close to 2%, and our overall like the degradation, our temperature coefficient, our low light performance is all better than PERC, more than 10%. So that's the left side map is our simulation based on the PV system, and we can see there is just a very obvious advantage compared to PERC, and it replaced the PERC just in this very short 2 years. And the Topcon, I think, currently is our major competitors compared to our first generation, because we should admit that Topcon has its very extraordinary performance, and his bifacial rate is very good. But LONGi HPBC have his unique point. Firstly, is about the low light performance. Because BC have no front side bus bar or fingers, it can absorb more sunlight. So especially in the sunlight, we can see that the amber numbers is changed. So we can replay this video. We can see that dashboard, this amber numbers. We can see that the BC amber number is higher than Topcon from the very low light condition. And at sunrise, we can see that it's amber get closed, but as sun drops, the amber BC have its own advantages. So that's our first unique point. And secondly, is about the BC's very unique electrode, because I think this year Topcon was exposed and very big risk, very big reliability issues because its DH performance is not that good from the RETC or PVEO. This two third-party test department, but BC do not have that issues because from the technical side, because of the front side Topcon adapt the aluminum and the silver alloy, and this alloy is very easy to get a corrosion and the humidity environment, so it will have the DH performance is not very good. But our HPBC first generation, you do not have that issues because we not use this special alloy. We use silver or the aluminum, the pure silver or aluminum to achieve the ohmic contact to transmit the current. So we do not have that DH issues. Also, there are some the element lead is also another key factor that affect the DH performance. So we do not have that much lead. We just 1/6 of the 1/6 lead percentage compared to Topcon. That's our another unique performance in the humidity and heat environment. And there is a real case comparison compared to Topcon. The HPBC cells have around 1% power generation gain per watt. Yeah, that's one of our customer real case testament. Based on our first generation HPBC, we launched our HiMOIC 6 product family to the market and to 2022, and we adapt to M10 wafer, and our dimension is that. And because our BC is mainly focused on the distributor market and firstly and that year, and so we divided our product into 4 family members: Explorer, Scientist, Guardian, and Artist. Explorer is meet the major market. It's not have very special function, but its performance is very good. And Scientist is have the higher power compared to the mainstream modules, so you could meet the demand in some high energy consumption scenarios like some industry or some logistic warehouse like that. And for Guardian, it's just try to meet the demand of some very special function like our anti-dust. Anti-dust is launched in October last year, so it's very popular, and a lot of our competitors, our industry colleagues, try to copy this very special structures to meet the customer needs. And Artist is focused on the authentic side, especially at the residential side scenarios, because like some villa or some yard, you want to store the module on the rooftop, and also want to enhance the overall performance of your asset. You can choose these modules. And this year, we just debuted our HiMOIC 6 Max, because why call it Max? Because firstly, we adapted the M11 wafer and adapted our Tyree wafer. It's a M11 Tyree inside wafer. Tyree then is And the wafer level is our very important and strategic technologies for LONGi, and we also will respond to the standardization, the module standardization, and we change our 72 cell modules into the 2382 millimeters dimension. It's not only an size enlargement, but also it's overall performance enhancement. And we refine our three characteristics for our overall HiMO X6 Max product family is high quality, high reliability, and high technology. Quality is about the performance, about our materials, raw materials like the glass, a frame we use, and reliability is about our LONGi's long-term reliability guarantee. We have very strict test environments. We have very strict test standards compared to the IEC, and we just try to guarantee reliability for our internal productions. And for the technologies, super obvious. So firstly, the BC is a cutting edge technologies, and also we have, based on that, we have our like anti-dust or anti-humidity and heat with special encapsulation structure to achieve higher performance. And we still have these 4 family members, and we just keep it and try to meet the different customer demand through these 4 family members. And this is our portfolio, and we would have X6 and X6 Max in the market for a little time, but we'll gradually switch our all product into Max because we think the Max is can add more customer values and bring more the true value to the customer and reduce the customer cost in a lot of respects, in a lot of aspects. Then it's so as I said before, and the last 2 years is May in Madrid, we published our second generation, which compared to the first generation is a huge jump. And our first generation HPBC, our module sale is around 25.5 to 25.8. But for our second generations, our cell efficiency is more than 26.6 and can even achieve 27. It's very close to our record created by ourselves, because our 27.3 is and our BC the world BC record, world sale record, created by LONGi and the last year December. And so the second generation BC is very close to that record. It's very close to the limit. And we do the overall path variation improvement and to achieve better performance. I just list some point about our HPBC second generation, and we should all know that it's more than that, which I just list because of time limitation. Firstly, that because of our high efficiency, we can reduce the operating temperatures because as sunlight achieve the surface, there are just 2 ways they can go: heat or electricity. If you have higher power generation, you will have lower heat, and also the lower heat could enhance the power generation. So that it's a very positive cycle about it. So firstly, our HiMO could achieve our second generation could achieve higher efficiency and achieve lower temperatures. And also we have a very special functional point is about the improvement in the uneven irradiation, because I think the uneven irradiation is a major case in our environment, especially in the residential and CNI environment, because there always be some cloud or some airplane or some roof that some tree they would shade your modules in some angle, so that would affect your generations. And will even occur the hotspot. But if we have this special functional point, we can reduce the cost up to 90%. It's a very special one. And so that's a comparison. It's a parameter comparison. Except the bifacial factors, where I think HiMona is a very competitive, and I think compared to a Topcon and also compared to HJT because our efficiency is super high, and that's it. And we have lower degradation, lower temperature coefficient, and we have strong low radiation performance, and also some reliability things. And BC is a very good and distributed market because it's a front side no bus bar, it's a syntax. And HiMona actually focus on the utility scenarios because we just want to make a clarification like BC is not good at utility, but HiMona is better. So we just want to make this clarification to the market, to the adopt. And this is a simulation about the cost and income. So we have a lot of advantages. So we can overall achieve this level income in this 1.4 around square kilometers areas. It's a utility size scenarios, and that's our benefit could bring to the customer or to bring to the government. And this is and last I just have a few user case, and this is in Sweden where it's adapted our HMX6 scientist modules, and it's close to sea, and it's very beautiful actually. And it's in Finland. It's also on the rooftop. Can you adapt our scientist all black modules to not only meet your energy demand because and last year the electrical bill in Europe is crazy, but if we adapt to the PV modules, it can largely reduce the cost and also can bring the aesthetics and the beauty to your home. And the last one is about the industrial case in the Netherlands. It's a factor about the tulip, and it can largely reduce the cost about the company operation and especially and the electricity usage, and bring the to green and natural electrical plantations to the market. Yeah, that's it. That's all my presentation. So thank you for listening. Anyone have answer or discussion, we can talk about that.
Okay, thank you, Dante. I think it's a very interesting presentation, and there are really a lot of questions in the chat window. Some, anyway, I would also like to ask, but since you have used up all your time, I would like to move on to the next presentation. So please enjoy our conference and also answer the questions in the chat window.
Okay, yeah.